Hi there everyone, welcome back to Cody's Lab. So today's project is something that I've been sitting on for quite a while and I'm finally getting to it. In fact, this video was supposed to go up before the platinum from the road video, to give you an idea of just how long. But anyway, today I'm going to be extracting platinum and palladium from catalytic converters. It's actually a little closer look at what we got over here. We've got 3 catalytic converters here, one of which I've cut open so you can see inside. See that? There's the catalytic material. Right there. The material that was here, there's 2 sections in them, and I just take the one out and it's in this bag here. But the material that comes out of it looks like this. It's people call it honeycomb, but it's actually got like squares, so I wouldn't really call it honeycomb, but it's similar to that. But the material is made of a zirconium dioxide ceramic with an alumina wash coat, and the precious metals are in that outer wash coat. Now I have checked these with my X-ray fluorescent spectrometer, and indeed I do see spikes in the data indicating platinum and palladium. This box over here is some material that I actually purchased on eBay. It's 10 pounds of ceramic from the catalytic converters, and when I check this with the X-ray, I see only a very little amount of platinum and almost no palladium. This tells me that somebody ripped me off. They had processed this prior to sending it to me. So if you're buying stuff on eBay, be sure to get intact catalytic converters that somebody hasn't already messed with. I mean, catalytic converters do lose material over time. You know, the exhaust reacts with the precious metals, and it does lose a little bit over time, but it doesn't lose this much. But anyway, I think because of that, I'm actually going to be omitting this from our little run here. So we're just going to have the material from, I believe this is about 5 catalytic converters right here. So we'll be able to see how much metal we can extract from that. So the first thing we've got to do is get the catalytic material out of the catalytic converter. Now you could either cut it open with a grinder, which you can do, but is a pain, or what I'm going to do for this one is take a rod, preferably a metal rod, but this is a wooden rod, it'll do, and just beat the material out of the converter. Just rod it out. So I ended up cutting this one open because it was rather hard to rod out. The 2-chamber design makes it rather difficult. You can see it's got this stainless steel mesh surrounding the ceramic core. We don't need any of that. Ceramic is what we're after. Let's see if I can pry this out of there. Oh, I broke it a little bit. There you go. Looks just like that when it's intact. One thing that I think is kind of cool that you can do with this catalytic material is you can set it up and then heat it with a blowtorch, just like this. And you can turn off the torch, turn it back on without lighting it, and you see that the spot stays hot because the platinum and palladium is reacting with the oxygen and propane, actually causing it to burn without a flame. See now, it's cooled off almost completely. Let's hit it again, see if I can get it to come back. So, no flame, but it heats up. So now, it's just a simple matter of taking this catalytic converter material and stuffing it into this glass vessel here. If it's small enough to fit into the jug, just throw it in. There's no sense crushing it any finer than you need to. If it's too big to fit, well, you are going to have to break it up a little bit. If I was a little smarter, I might put on a respirator for this. In fact, you know what? I think I'm going to. Who knows what this does to your lungs. So as you can see, all of the catalytic converter material has been placed inside of the jar, Now it's time to make up the leach solution. Now the primary component is of course going to be water. So I'm going to dump in enough of this distilled water to fill it up to the point where it covers the catalytic converter. Where's that funnel? Alright, that's probably just about what we need for the water. So now I'm going to put in some hydrochloric acid. I'll probably only need a few milliliters really to dissolve all the platinum group metals, but there's going to be a lot of side reactions happening. So I put in roughly a liter of acid just so that it remains in solution strong enough to dissolve the platinum group metals. Now this solution as is will not dissolve our precious metals. It might dissolve iron and nickel, but that's about it. In order to get it to dissolve those other metals, I have to add an oxidizer. In this case I'm going to be using calcium hypochlorite, which will make chlorine gas when it reacts with the hydrochloric acid. Chlorine gas will be trapped inside of the bottle and should dissolve into the liquid, and will be able to oxidize the platinum so that the hydrochloric acid can further dissolve it. Here we go, I'm just going to add it in a little at a time. You see the bottle become a little bit yellow-green there as the chlorine gas is being evolved. And you'll also notice I'm using a stopper which has been wrapped in Teflon tape, because the Teflon is a lot more resistant to the chlorine than the rubber ever thought of being. So now I'll just kind of mix this around a little bit to get that chlorine gas to dissolve into the liquid. And let it sit for a few minutes, and then I'll add a little bit more. It doesn't really need a lot of chlorine, but there is a lot of side reactions happening, so I want to have quite a bit of an excess available. Let's go ahead and give it the second dose now. And there we go. Alright, that's looking pretty good. See, the bottle's still green, so I'll probably leave it like this for an hour or two before I add another dose. Probably only give it a couple more doses before the solution's saturated in chlorine. Here it is over in the sunlight, so you can maybe see it a little bit better. You can definitely see the chlorine gas. Just mix this around occasionally, and that should dissolve the platinum and palladium. So I can already see that the solution is changing color as it dissolves those precious metals. That's a good sign. I'd say about the first 50% of the metals are dissolved within the first hour. I will leave this in here for about a week though, because in my testing I found that after about a week is where I stopped recovering any of the metal. I've done some small scale tests here. So yeah, I'm going to leave this sitting probably either outside or in my fume hood for about a week. Chlorine's some nasty stuff, so I definitely don't want to store this anywhere where I'm going to be living. I'll see you guys when this is done.